Hey, me313. Hope your first week's going well. I got a quick little tip I wanted to give you about using software that you might find useful for the class. So let me go ahead and introduce that here. And so what I'm going to do is actually use this problem that was out of the homework set. You probably read into this is out of chapter 7, where it's asking about, we got this compressor, we got an inlet conditions are given, we're told the entropy stays constant, so it's isentropic. We're given the outlet pressure and it's asking for what the outlet temperature and enthalpy are. It's sort of straightforward. However, one of the things you might have noticed is that the inlet conditions, 35 kilopascals, 160 degrees Celsius, if you go over the tables and you want to look up a value of entropy to look for what that value is, you'll look, right, I've got 10 megapascal or 10 kilopascals in this table, 50 kilopascals here. I need 35. You would need to interpolate a value in between it. And then 160 degrees also falls in between these two values, and so you would need to do another interpolation. So you would need essentially a double interpolation and to get that value just to get your value of S. And then you need to do that again for your enthalpy, and you need to do it at the outlet. And you might find that this time you've done about 7 interpolations and you're kind of sick of it. It's a little bit of kind of a caveman approach to it. And one of the things I'd like you to do is start using some modern tools in this class. You'll find this very useful for other things. So let me show you a quicker way to do this problem. So first what I'm going to do is I'm going to go ahead and show you how to do it in EES. And so this is a fairly powerful program, and you can solve this problem fairly quickly. So for example, if you wanted to know the entropy at those conditions, I could say S1 equals entropy, which is the function. And I want it for water, and then you give those conditions. So I'd say P is equal to 35 for the pressure, and T is equal to 160. And then I can go ahead and just hit calculate, the little calculator button, or hit F2, and there's my entropy value, right? So I didn't need to do any interpolations, or actually 3 interpolations in order to get there. It was fairly quick. And in fact, we can go ahead and finish solving this problem because we know that the outlet would be the inlet. I could just say S2 is equal to S1, and then go ahead and have EES tell me what those conditions are at the outlet. So I'll say S2 is, and the outlet pressure was 300. The outlet temperature, we don't know. That's what they want us to find. I'm going to go ahead and have EES find that for me. And there it is. And so it says that the temperature is 439. And if I come back to my problem, it was 440, close enough, right? So fairly quick there. And in fact, the other thing I wanted to know was what the outlet enthalpy was. We can go ahead and do that pretty quick here. I'll go ahead and call that H2, and then that's going to be, the function would be enthalpy, same conditions, and there's my outlet enthalpy, 3357, right? So pretty quick on doing the homework problem there. I can show you another way to do it if you don't want to use EES. There's actually a site here called the Test TEST. It's a website. You can go ahead and solve this problem in here as well. So I'll show you really quickly on that one since we got some time. So I'm going to go ahead and navigate through and go ahead and we'll just solve a simple closed steady problem with a phase change. And what you end up with this little interface here where it's kind of a spreadsheet and you just enter the numbers. So again, I'm going to go ahead and say the pressures was, they gave it to me at 35, right? And what was my temperature? I've forgotten the problem already. Was 160. All right, so let me come back over here, and I'm just going to go ahead and type that in there, which is 160, and click this calculate button, and there we go. There's my enthalpy value, or my entropy value of S2. So what I could do to make this a nice entropic, I'm just going to add another state. So I'll go ahead and call this state 2. This now my pressure is 300, and we know that S2 was, it's like a spreadsheet. I'll say it's equal to S1, and it's going to grab the value from the previous chart. I can go ahead and hit solve, and it's going to go ahead and give it to me. There's my temperature, 439, close enough to 440, and there's my enthalpy value, 3359. So there we wanted to solve that problem twice on 2 different ones. So anyway, I think you'll find using software tools are fairly easy, really help you out in this class. So anyway, hope that tip was helpful. See you later.